This is a video from section 3.4 and it's on the chain rule. If y equals f of u and u equals g of x are both differentiable functions, then dy dx is equal to dy du times du dx. And one thing I want to note in this video, this is a version of the chain rule. And there is another version of it that I will save for a different video. Now, let's look at some examples. Suppose I said find the derivative of the function. Let's look at example 1. If I'm given f of x equals x to the 5th plus 3x squared minus x to the 50th power. Now, I'm going to let u equal the inside function. All right? So we're going to let that be x to the 5th plus 3x squared minus x. Can we agree that y is then equal to u to the 50th power? And so if I want the derivative, f prime of x, that's going to be this. It's going to be dy du times du dx. So let's take a look at this. If I apply the power rule directly, the derivative of y with respect to u is 50u to the 49th power. And du dx, so the derivative of u with respect to x, is 5x to the 4th plus 6x minus 1. And so what I want to do is put all that together. And so this is 50u to the 49th times 5x to the 4th plus 6x minus 1. But can we agree that u is equal to x to the 5th plus 3x squared minus x? And so what that says is f prime of x is going to be 50 times u, but u is x to the 5th plus 3x squared minus x raised to the 49th power times the derivative of u with respect to x, but that's 5x to the 4th plus 6x minus 1. And that right there is how you do the chain rule. So let's take a look at another example. Suppose I had the following. Suppose I did g of x is equal to e to the x squared minus x. So I'm going to let u be equal to x squared minus x. That's the inside function, if you will. And what that says is y is equal to e to the u. Du dx is 2x minus 1, and dy du is equal to e to the u. I hope that's okay. So now, if I want g prime of x, that's going to be equal to dy du times du dx. But dy du is e to the u. Du dx is, let's take a look, we got 2x minus 1. But remember that u is x squared minus x. And so therefore, g prime of x is e to the x squared minus x multiplied by 2x minus 1. And that's example 2. Let's take a look at example 3. Suppose I had the following. Suppose I had y equals cosine theta squared. Or, well, let's make it better. We'll call it f of theta. So it's a function of theta. So the inside function is u. So we're going to let u be cosine of theta. And that says that y is equal to u squared. But du d theta is negative sine theta. And dy du is equal to 2u. Okay? And so if I want f prime of theta, this is dy du. I hope you guys are seeing the pattern. I'm always going for the inside function times du d theta. But dy du is 2u. And then du d theta is negative sine theta. But remember that u is cosine theta. And so therefore, f prime of theta is negative 2 cosine theta sine theta. But that's equal to negative sine 2 theta. And that right there is example 3. I want to do one more example for you here. We'll call this example 4. Suppose I had the following. Suppose f of t is equal to tangent of square root of 1 plus t squared. Suppose I had something like that. So the question is, what would I do with that? Now, the inside function is going to be 1 plus t squared. And so that says that y is equal to square root of u. But I'm not quite done. Okay? And so what I'm going to do next, and this is maybe where it's a little tricky, is I'm going to let z be tangent of y. So let's see if we can track me here. Can we agree that dz dy is equal to secant squared y? Okay. And then dy du is 1/2 u to the negative 1/2, which I claim is 1/2 times the square root of u. Okay, and then du dt is 2t. So what I'm going to do is I'm going to put all those things together. So therefore, f prime of t is the following. We're going to take dz dy times dy du times du dt. So it's kind of an extension of that chain rule that we just learned. dz dy is secant squared y. dy du is 1/2 times the square root of u. And du dt is 2t. Now what we need to do is put everything in terms of t. Okay? Now, y is square root of u. So let me write that down. So I'm going to have secant squared of square root of u times 1/2 times the square root of. Now u was 1 plus t squared. So I'm going to put 1 plus t squared. And then I'm going to multiply by 2t. But the 2's cancel. And so this is secant squared of square root of 1 plus t squared times t divided by square root of 1 plus t squared. And that concludes this video for section 3.4. This is 4 examples on the chain rule. And we did a version of the chain rule called Leibnitz notation. And there is an alternate version of the chain rule that I will introduce in another video. Okay, thank you.